All right, everybody, welcome to Module 2, Chapter 2 and 3, Math for Teachers solo lesson. My name is Toni Breshears, and let's get started. Okay, so design a Venn diagram to show all elements of U. Okay, so U is our universe, and then our little diagram inside with the three circles, we have circle A, circle B, circle C, and then anything in the middle here, like this section here, is what is in both A and B, and then this is what's in both B and C, and this one is it. This one is A and C, and then here, this small area in here, that is it. That is what's in both A, B, and C. Okay, so our universe, which is our entire box with our Venn diagram inside, it contains A, B, C, D, E, F, G, and H. A contains A, B, C, D, G, and H, and then B contains D, F, and H, and then C is D, G, and H. So, automatically, our A is the only thing that's not in, our lowercase a is the only thing that is not in any of these other elements. But B is in, as we see here, it's in A and B. So C is also in, C is in just our A. And then now D, if you go down, you can see that D is in our universe, our A, our B, and our C. So it'll go in the middle here. And then now our E, well, that also is in neither our A, B, and C. So it only is in the universe. So now our F is only located in B. So going down the line, G is in A and C, so it'll go there. And then H is in our universe, our A, our B, and our C. So it'll go in the middle with D. Okay, so we have U equals union, which is or. N equals intersection, which is and then we have X with the line over the top is complement, which equals not. So what we're going to do here is we're going to solve these problems. What is in B union C? Well, union is or, so it can be in either B or C. So F is the only thing that is in B or C. It can't be in A. It has to be in just B or C. So, oh, well, it can be part of A, but it has to be in B or C. It's not saying not A, but okay, so anything in B or C. So F, D, F, G, and H are in B or C because C, you can see here, it's in, these are in B, circle B, and then this is in circle C. Okay, so now we have A intersection B, which is A and B. It has to be in both. So D and H, because here it is in A and B. It's in both of them. B, we have B and C. So what is in both B and C? Well, it has to be in both of them, not just separate. So now we have D and H because they both share D and H. Now, A union C, which is A or C. So anything in A or C. So that's going to be our B, C, D, H, and G. So B, C, D, H, and G, or D, G, and H. Now what we want is everything in A, which is A, E, and F. Everything that's not in A. Okay. So we have our complement up here, which is not A. So all of these letters are part of A. They might, our D and H are in B and C, but they're still a part of A. And then G is in A and C, but it's in C, but it's also a part of A. So that cannot be in our complement of A. So anything out of A is A, E, and F. So now we want our A intersection C. So what's in A and C? So pretty much that's going to be our B, C, G, D, and H. Well, A and C is what is in both of them, not in either or. So, which is D, G, and H. Okay, and so now the next one looks trickier, but it's not as hard as you would think it is. So we have our A, we want it has to be in A or B and C. So A union B intersection C. So that is going to be B, C, D, G, and H. So B, C, D, G, and H. So it's in everything in A and everything that is in B and C. So this is what's in B and C, and this is everything in A. So next. Okay, so now A equals, everything in A equals B, C, D, G, and H. And then everything in, we have B and C, which is D and H. And then now on to our next problem. Okay, so here we have a different way of working our Venn diagram. Okay, so this is how we're going to do this. Okay, demonstrate which shapes are found in the set L and H, because we're still using our union and our complement and our intersection. So our union, so we have L and H. So L and H is, if you look, we have everything labeled. We've got our circles, we've got our triangles, our hexagons. They're either blue and some are small, we have large, and then we have red. Our red here is our pink ones. Okay, so demonstrate which shapes are found in sets L and H. Well, L and H is large and hexagon. So a large hexagon is going to be these right here. Okay, so now we're going to demonstrate which shapes are found in the set C or H. Okay, so C is a circle and then H is a hexagon. So all circles and all hexagons are going to be C or H. So now demonstrate which shapes are found in the set, not T, our line here is supposed to be over here, but not T and red. So as long as they're not a triangle and they're red, they fit what we're looking for. So not triangles and only red shapes. So we have our big circle, big hexagon, and little hexagon. As long as they're red and not triangles, we're good. Okay, demonstrate which shapes are found in the set C and S and R. So as long as they're a circle, they're small, and they're red, then they fit what we're looking for. And that is our one little small circle here. Okay, so now on to our next. Write the Indo-Arabic equivalent of each of the following problems. Okay, so here we go. Egyptian system. Okay, so you see here we have little fingers, what looks like ends, and then what looks like little one symbols. Okay, so here's what we're going to do. We have 3 fingers, so that is 10,000 per finger, per pointer finger. And so we're going to do 3 times 10,000 plus, and then we're going to do 1, 2, 3, 4, and 5. We have 5 of the heel bones, and those are 10 apiece. So we'll do 5 times 10, and then we'll do plus, and then we have our little strokes, or our staffs as it calls them. We've got 1, 2, 3, and 4. So we have 4 of those, and they equal 1. So 3 times 10,000 is 30. It's 30,000. Plus 5 times 10 is 50, and then 1 times 4 is 4. So we have 30,054 for our Egyptian system. Now, we have our Roman numeral system, which you may or may not have heard of Roman numerals, but it's using letters as numbers. So we have MCM XXX V11. or VII, my bad, VII. Okay, so now our M equals 1,000, so we'll do 1,000. Our CM, now when you have, our C is worth 100, but our M is worth 1,000. So when you have a larger number behind a smaller number, it is telling you, well, when you have a larger letter behind a smaller letter, then you're supposed to subtract what number it equals. So you would do M, which is 1,000, minus 100, which is C, which gives you 900. And then you have X, X, X. So there's each X equals 10. And so 10 times 3 of the X's equals 30. And then you have one V, and V equals 5. And then you have 2 I's. And so they equal 1. So 1 times 2 equals 2. So you do 1,000 plus 900 plus 30 plus 5 plus 2, which gives you 1,937. All right, on to our next one, our Babylonian system. Okay, so this one looks a little weird, but it's the same as the rest of them. You just have to connect the pictures with the numbers. Okay, so now we have 1, 2, 3, 4. We have 4 arrows, and when we look, our arrows are pointing this way. So only one of our pictures over here is pointing that way, our little arrow. So that is our 10. So we have 4 of those, so 4 times 10 is 30. Now we have this one little triangle that's upside down, and there's only one of them. It only has one. So that means we have one of those, and it is a 1. So 1 times 1 is 1. So 40 plus 1 equals 41. I don't know why that says 30, but 4 times 10 is 40. So 41 is our answer for our Babylonian system. Now we have the Mayan numeral system. Okay, so this is how it works. Okay, so we have our pictures over here of what everything means. So over here we have a straight line, which over here shows is 5. And then we have a dashed line with one circle over it, which over here shows us a 6. And then we have 3 dots. 3 dots is our number 3. And then we have 3 straight lines above each other. And then we have 2 dots on top. So when you have the 2 dots on top, that gives you 17. Now, how do we work the Mayan place values? Well, everything is standing up here, up in this formation. So for us, that would be as if our number was going this way, and we'd have, say we have our ones, our tens, our hundreds, and our thousands. And then we have our 10,000s. Well, for them, it goes more like this. They've got their 7,200, their 360, their 20, and then their 1. For us, the 1 is the ones place, that is the tens place, that's the hundreds, and that's the thousands. So this is how it works for them. We're going to start at the top. So their thousands place is 7,200. Now they multiply that by the figure that they have and whatever the figure means, whatever number the figure is. So 7,200 times 5 is 36,000. So you'll keep that number, and then you'll do 360, which is their hundreds place, and you'll multiply that times the picture in your hundreds place, which is 6. So 360 times 6 is 2,160. And then their tens place is the 3. Their tens place is 20. But in the tens place is a 3. So you take the picture and then you connect the number, which is 3. 20 times 3 is 60. And then now their ones place is the 17. So 1 times 17 equals 17. So now when you add your 36,000, your 2,160, your 16, your 17 together, you get 38,237. All right, on to our next. How to use lattice multiplication. Okay, so what we're going to do is 28 times 32. This is a good way to solve any multiplication problem. You just have to figure out how to use your square and your, it's very easy to use. So you put your 28 on top, and then you'll put your 32 on the side, just like that. So now you'll do you'll do 2 times 3. 2 times 3 is 6, so you'll put your 0 here, and then your 6 here. And then you'll do 8. You'll do 2 times 2, which is 4, and then 8 times 3, which is 24, and then 1. Then you'll do your 8 times 2, which is 16. So now all you have to do is add them together. So 6, you add it by itself, then you'll do 4 plus 4, which is 8, and then you'll do plus 1 is 9, and so you'll put your 9 here, and then you'll do 6 plus 2, which is 8, plus 0 is still 8, and then you'll have your 0 here. So now your final number is 896. You'll use it this way. So there's nothing in the thousands. You got your hundreds, your tens, and your ones. So it's 896. 28 times 32 is 896. So now let's try a bigger square and bigger numbers. So you need as many squares across and down as many numbers as you have in each. So if you have 273 and it contains 3 numbers, then you'll need 3 squares going across. And then you have 628, so you'll have 3 squares going downward. So now we'll do 273 times 628. So now 2 times 6, we'll do 2 times 6 equals 12. And then we'll do 2 times 2 equals 4. 2 times 8 equals 16. And then we'll do 7 times 6, which is 42. 7 times 2 is 14. And then 7 times 8 is 56. And then we'll continue with 3 times 6 is 18. 3 times 2 is 6. And then 3 times 8 is 24. And so now when you add your numbers together, you get your 4. And then you do 6 plus 6, which is 12. And then 12 plus 2 is 14. So what do you do with that extra number? Well, you will hold your 1 up here in your next diagonal line. So I put our 1 up here on top of our 8. You could put it, if it was to get any confusing, you could put it on top of your 4, but it's best if you stick it at the top of your row. Okay, at the top of your diagonal line. So you do 8 plus 1, which is 9. 9 plus 4 is 13. And then 13 plus 6 is 19. And then 19 plus 5 is 24. Okay, so you'll do your 2 plus your 1, which is 3. You carry, because if it's 24, you'll carry your 2 up here at the top. Okay, so you'll do 2 plus 1, which is 3, plus 2 is 5, plus 1 is 6, and then 6 and 4, which is it's 10, and then 10 plus 1 is 11. So now you have another number that you have to carry. So you keep your 1 on the side here, and then you carry your 1 up here. Okay, so now you'll have 4 plus 1, which is 5, and you'll have 5 plus 2, which is 7. And you don't have to carry a number this time, so you just leave your 1 in that place. So now you have 171,444. Okay, so now let's calculate our next one. We have 964 times 593. So we'll put our numbers here at the top and then our numbers here at the side. Okay, so now 9 times 5 is 45. 9 times 9 is 81. 9 times 3 is 27. 6 times 5 is 30. 6 times 9 is 54. 6 times 3 is 18. 4 times 5 is 20. 4 times 9 is 36. And then 4 times 3 is 12. So we'll keep our 2. We add our 8, our 1, and our 6, which is 15. We carry our 1. And then we add 7 plus 1, which is 8. And then we'll add our 1 and gives us 9, plus 3 is 12, and plus 4 is 16. We'll carry our 1 again. We have 2 plus 1, which is 3. 3 plus 1 is 4, and then plus 2 is 6, plus 5 is 11. We carry our 1. 3 plus 1 is 4. 5 plus 4 is 9. And then 9 plus 8 is 17. We carry our 1. And so now we have a 1 up there at the top. So our final number would have been 4, but now that we had to carry a 1, it'll be 4 plus 1, which gives you 5. So our final answer is 571,652. So now on to our next one. So now we've got 4 place values. So we have to have 4 boxes at the top, and then since our other number still only has 3 place values, we'll have 243. So we'll only have 3 on the side. Okay, so now we do 4,952 at the top here and then 243 at the side. So 4 times 2 is 8, 9 times 2 is 18, 5 times 2 is 10, and 2 times 2 is 4, and then 4 times 4 is 16, 9 times 4 is 36, 5 times 4 is 20, 2 times 4 is 8, 4 times 3 is 12, 9 times 3 is 27, 5 times 3 is 15, 2 times 3 is 6. So now we just add them together. So we drop down our 6, then we add our 8 and our 5, which gives us 13. And then now we add our 4 and our 1, which is 5, plus 1 is 6, plus 7 is 13. We keep our 1. We do 2 plus 1 is 3, 3 plus 6 is 9, plus 2 is 11, plus 2 is 13. We keep our 1. So now we do 8 plus 2, which is 10, plus 3 is 13, plus 6 is 19, plus 1 is 20. So we carry our 2. So now 2 plus 1 is 3, plus 1 is 4, and then 8 plus 4 is 12. We carry our 1. So now we keep our 1, and that equals 1,203,336. I'm sorry, I got my place values wrong. But yes, 1,203,336. So now let's go to round to the leftmost digit to estimate the results of each problem. Okay, so we started out with 833 plus 465 over 134. So to round to the leftmost digit, we will have 883 is approximately 900. Our 465 is approximately 500. And then our 134, we round that down because the 134, if it was 5 and above, then we would round up. But since it is below 5, we'll round down. So 134 is approximately 100. So now we have 900 plus 500 over 100, which gives us 1,400 over 100, which gives us 14. So now, if we don't round to the leftmost digit, then we have 883 plus 465 over 134, which equals 1,348 over 134. And that gives us 10.06. Now, it's not super close, but it is close enough to tell you that you got your calculations right. Okay, so now we have 5 times 254 plus 523 over 35 plus 7. So now we're going to round. 254 is approximately 300. 523 is approximately 542. Approximately 40. Oh, okay. Okay. So that kind of messed up there for a second. I don't know why I did that. Okay, so 5 times 254 plus 523 over 42. Okay, so 54 is close to 300, and then 523 is close to 500, and then 42 is close to 40. So you have, you'll do 5 times 200, you'll do 5 times 300, which is 1,500, plus 500 over 40, and that's 2,000 over 40, and that gives you 50 when you divide 2,000 by 40. Now you've got 5 times 254 plus 523, and then you have 35 over 35 plus 7. So now you have 1,270 plus 523 over 42, and that is 1,793 over 42. And when you divide that, it gives you 42.69. So that's pretty close to 50. So now we'll do 620 times 430 over 293. So 620 is approximately 600. 430 is approximately 400, and 293 is approximately 300. So 600 times 400 over 300. And that gives you 240,000 over 300. So now, when you divide those 240,000 divided by 300, you get 800. So without rounding to the leftmost digit, we still have 620 times 430 divided by 293. And when you do that, you get 266,600 over 293. When you divide that, you get 909.9. So now on to our next problem. How to perform arithmetic in bases other than 10. Okay, so this one seems kind of tricky. So you have 432 with a base of 5 plus 133 with the base of 5. Okay, so when you're counting numbers and you've got, say, we'll use these. Say you've got over 11 squares here. You count when you get to having 10 or 11, when you get to having your 11, you'll put your 1 here, and you'll carry a 1. But now, instead of counting up to 10, you just count up to 5. And whenever you count up to 5, you treat it like it's a 10. You carry your 1 over and you put your 0. Or if you have 6, then you'll count up to 5. You'll have 1 left over. You'll keep your 1 and you'll carry your 1 over. And now we'll get visual with it. Okay, so now we're going to add 432 with the base of 5 plus 133 with the base of 5. So this is our 432, and this is our 133. So now, we're going to add 1, 2, 3, 4, and 5. So I cross those out so you know we already counted them. Okay, so they come to a 5. So now we get rid of those. We put our 0 because now there's nothing to hold that place. There's a 0, and we add our 1. So now we're going to add our 4 and our 3. So 4 plus 3, 1, 2, 3, 4, 5. Okay, so that's 5. And now when you add our 5, you're going to drop whatever's remaining. So you have 2 remaining. You've got your 1 we added, and then you have 1 that was already there. So you have 2 remaining, and you carry your 1. So now we're going to add what's in our hundreds place. 1, 2, 3, 4, and 5. Okay, so we get rid of those 5 because now we're going to carry those over. And we have 1 remaining. So you're going to keep your 1, you're going to carry your 1,000, the 1 you added, and that's going to be a thousands placeholder. And so now there's only 1 there, so you drop your 1, and now you have 1,120. Okay, on to 628 with a base of 6 plus 738 with a base of 6. Okay, same way. Instead of counting up to 5, we're going to be counting up to 6. So now these equals 6. So we're going to drop those, and we're going to carry over our 6. Remaining is 1, 2, 3, 4, and 5. So you keep your 5 and you carry your 1. So now we're going to do the same thing. We get rid of 6 here. So now what is our remainder? 1, 2, 3, 4. So we're going to drop our 4. We're going to carry our 1 over to the hundreds place. So now we've got 6 here, and we have a 1 remainder. So we're going to drop our 1, and we're going to carry the 1 over. So now our thousands place, there's only 1 in the thousands place, so we're going to drop our 1. So we have 1,145. Let's try this. Okay, so we have 414 with a base of 5 minus 43 with a base of 5. So when you do this, you only want to put your largest number that you're subtracting from. Okay, so we're going to subtract 3. So now that we've subtracted 3, we only have 1, so we're going to drop our 1. And then, how are we going to subtract 4 from our 1? Well, we can't. So we're going to have to break it down. We're going to have to borrow. So we're going to borrow 1 of our hundreds place. We're going to add 4. And we're going to add 5 onto our tens place because, instead of adding 10 like you would originally when you borrow from another number, we're just adding because their base is 5, we're going to add 5. So now what you do is you count off 5 because you count off your 4, your 1, 2, 3, and 4. What your remainder is 2. So you drop your 2, and now you can take what you have left because there's nothing to subtract from our hundreds place. So you drop your 3. So now our answer is 321. Okay, so now let's do 503 with a base of 5 minus 24 with the base of 5. So we're going to take our 500 and our 3. So now you can't subtract 4 from 3, so we have to borrow, because there's nothing to borrow from our tens place. We're going to borrow from our hundreds place, and then we'll borrow from the tens place when we get something in that place value. Okay, so now we're going to add 5, because 5 is our base. It's no longer 10. So we add 5. So now we need to borrow from one of those 5 to add to our ones place so we can subtract 4. So we subtract 1. So we borrow 1, and then we add 5 in our ones place. So now we have 1, 2, 3, 4, 5, 6, 7, and 8. We have 8 spots in our ones place. So now we're going to subtract 4, and we have 4 remainder. So now we have 1, 2, 3, and 4. We have 4 in our tens place, and we only have to subtract 2. So now you subtract 2, and now we have 2 remainder. So you drop down your 2. And because we were only subtracting 24 from 503, whatever's left over in our hundreds place, we can drop down. So now, remember we borrowed from our hundreds place. So now we have 3 and 4. So we drop down our 4, and our answer is 424. All right, well, that concludes our video for today. Thank you very much. I hope you learned a lot and enjoyed my lesson. And y'all have a great day.